Hello everyone. My name is Liu Jiahe. My metric number is BC260299, and my major is computer science. The next one.
Hello everyone, my name is Yang Jingyuan and my metric number is BC260249 and my major is computer science.
Hello everyone, my name is Tracy Yue. My metric number is BC260272 and my major is software.
Hello everyone, my name is Gao Yitao and my metric number is BC2602C2. My major is multimedia computing.
Good morning, respected teachers and dear classmates. Today we are talking about mathematical interaction and its hidden logic in daily life. Many see it as just an abstract exam tool, but actually this reasoning rule connects with our ordinary moments. It shapes how we judge patterns, events, and summarize experiences, quality guiding our discretion every day. Mathematical interaction rests on two simple steps. First, prove the starting case works. Second, prove that if any case works, the next one does too. That's it. With those two, we can conclude the rule holds for all cases. Now to valid daily examples. First, the damping effects. Clock on the first demo, that's the base case. Then ensure each failing demo talks down the next. That's the index step. Without watching every press, we know all will fail. This perfectly shows instructions power. Second, climbing stars. To research the top, we first step onto the first star. Then we can move from any star to the next. We'll keep going. We don't test each steps beforehand. We trust the rule, just like instruction. So mathematical instruction is never confined to the textbook. From domino to stars, from daily routine to scale learning, its logic appears everywhere. It teaches our to see the whole picture, not just isolated events. We hope today's start help you discover more mathematical thinking in our daily life. Thank you for your listening. Okay, next one.
Okay, thank you, Liu. So next we will learn recursion and mathematical introductions through three daily examples. So first example, building at the supermarket. Recursion has two key parts, base case and recursive step. The base case is the first customer who can pay right away. The recursive step is a rule. You must wait for everyone in front of you. If six people are ahead, you wait for all six. Everyone follows the same rule. So next we will go into example 2. Cooking rice. Every step relies fully on the last step, finishing. The fixed routine repeats every time we cook. Empty pot, add rice, rinse, add water, cook. The empty pot is our starting base case. Then we will go into example 3, watering plants weekly. Week 1 is our base case. The first watering, we repeat this action every week after that in a circle. And now Let's quickly sum up recursion's two core trains. First, everyone recursive scenario has a clear starting base case to stop endless repetition. Second, a fixed recursive step repeats identical actions based on the finish. This daily case help us grasp mathematical introduction easily. Its based step matches out our starting points and the inductive step mirrors, repeating the same rule. Recursion and introduction are not abstract math. We can see their full logic in ordinary daily life. That's all about my part.
Hello everyone. Today I want to share 4 short stories. They all show the same powerful idea, mathematical induction. Story 1, the ball passing game. Imagine n people standing in a line. The ball starts with the first person. Each time you can pass to the next person or skip one person. How many ways are there to reach the nth person? We find a rule. To reach person n, you must come from person n minus 1 or person n minus 2. So the number of ways in is fn equal fn minus 2 minus fn minus 1 plus fn minus 2. We also know f1 equal 1 and f2 equal 1. With these starting values, we can compute for any n. This is induction. Find a starting point and step-by-step rule. Story 2. Gears. A row of gears are tightly connected. If we turn the first gear, all gears will turn. Why? Because the first turns the second turns the third, and so on. If second turns the third, and so on, if we assume the key gear turns, the mesh with the next gear, the k plus 1 gear also turns. Induction is like dominoes, push the first one and all the rest fall. Story 3, sunflower seeds. You pick a few seeds from a bank. The first few are good, so you start to believe the next one will be good too. This is everyday induction. But it's fragile. If you suddenly find a bent seed, you trust bricks. This reminds us that induction only works if the chain is absolutely reliable. In real life, chains often break, so we must be careful. Story 4, family surname. The first male census has a surname Wang. The family strictly follows the rule son takes father's surname. Then the second generation is Wang. The third is Wang, and all future generations are Wang. This is the cleanest example of induction. A clear starting point and a fixed rule that always holds. So the conclusion is certain. Okay, next one.
Hello, everyone. As the final speaker of our group, I'd like to bring all our thoughts together. We've looked at the climbing stairs, curing, and daily habits. Each of these examples serves as a bridge between code, abstract mathematics, and the warmth of our daily lives. Whether we are solving a math problem or trying to build a career, we are all using the same logic, the logic of a communication. Let's look at the example of the piggy bank. A simple tool for a profound lesson. If we save 1 yuan on day 1, 2 on day 2, and n on day n, we are essentially performing a mathematical induction in real life. The base case, you must start today. A journey of 1,000 miles begins with a single coin. The inductive steps, if you can succeed today, you can succeed tomorrow by repeating the same rule. This is how we conquer challenges. We don't need to see the top of the mountain to start. We only need to know how to take the next step. When we look back at our 4 cases, the truth is simple. Order is everything. Skipping a day in the piggy bank or skipping a step in your study breaks the chain of growth. We've learned that small, sustainable actions are far more powerful than sporadic, massive efforts, as the math shows. Your future self will be grateful for the discipline you practice today. So, what is the one thing we hope you carry home today? It is this: small actions repeated in order are not small at all. They are the only honest way to build something that lasts. A piggy bank doesn't need to understand complex formulas to be effective. It just needs. We hope you will apply this recursive mindset to your own lives. That yesterday's discipline becomes your foundation, and today's foundation becomes your future possibility. Thank you for your time and for joining us on this mathematical journey. We are happy to take any question.